Hello, everyone, and thank you for joining. In this session, we're going to talk about industrial IoT cloud-based management platforms and how they can be exploited by hackers and actually act as a backdoor for accessing multiple industrial environments at once. My name is Roni Gavrilov. I'm working as a security researcher at Autorio. Autorio is an industrial cybersecurity company providing solutions and services for industrial environments. So what we're going to talk about, we'll start with some background about Industry 4.0 concept and industrial IoT devices and their cloud-based management platforms. Then we will move to our motivation and the question that we tried to answer during the research. Is it actually possible to breach to industrial environments by targeting cloud-managed industrial IoT devices over their cloud platform, using their cloud platform to pivot into the industrial environments? Then we will dive into the attack vectors we covered in the research. This will be our main topic. We will see some zero-day vulnerabilities we discovered alongside a very cool exploitation demos. At the end, I will share some recommendations for clients and vendors and some key takeaways from the research. So Industry 4.0 is a common term in the industrial lexicon. It refers to the integration of advanced technologies into the manufacturing and production process. Technologies such as artificial intelligence, edge computing, robotics, big data analytics, and Internet of Things, or industrial Internet of Things, which plays a crucial role in the Industry 4.0 by enabling devices and systems to communicate with each other in real time, and by that leading to better decision-making and improved efficiency. There are different types of industrial IoT devices, including sensors, meters, controllers, HMIs, and different network devices. A very common and popular one is industrial cellular routers and gateways. They're used to enable a secure remote access between industrial equipment in remote sites over the cellular network to the control center. They typically featured with a rugged design to operate in industrial environments. They're supporting different industrial protocols such as Modbus and DNP3. Usually they have a Wi-Fi functionality. They have built-in security functionalities like IPsec, VPN, and a firewall. And another feature they commonly have is the vendor cloud-based management platform for remote management of the devices. Those platforms provided by the vendors as a service, usually as a paid service. Users can create an account on the cloud platform and register the devices under their account and remotely manage the devices, see their alerts and statistics. Operations like configuration changes, firmware upgrade, reboot, and others can be done over the cloud platform without the need of the device owner to physically travel to each location. So during our research, we decided to focus on industrial cellular routers and gateways as our industrial IoT device for the research for three main reasons. First, they are very common on different industrial sectors and critical infrastructure as a remote connectivity solution. They can be found in substations, water utilities, oil fields, and pipelines. Second, according to some research, more than 4.5 million devices were shipped globally during 2021, so they are quite popular. And three, successful exploitation of the industrial cellular routers and gateways by attackers could have two potential impacts, a local impact and a remote impact. The local impact, since the industrial devices and protocols are insecure by design, an attacker with direct access to them can easily manipulate and impact the process. For example, stop the oil production in oil field. And the remote impact, leveraging the built-in VPN on the device, if in use, an attacker can use the VPN credential in order to perform lateral movement to the other side of the VPN connection, where the SCADA server is located. So there are different vendors manufacturing industrial cellular routers and gateways. And here you can see some of them. Each of the vendors is providing his own cloud-based management platform for remote management of their devices. And this actually leads us to our research question. If attackers decide to target a single vendor cloud management platform, is it actually possible over the cloud platform compromise the cloud-managed industrial cellular routers and gateways? and by that get internal access to the industrial network? So as you probably guessed, the answer is yes. During our research, we checked 3 leading vendors, in-end networks, Teltonika Networks, and Sierra Wireless, and we found it to be possible. But before we dive into our findings and the attack vectors we covered, let's break the cloud management platform into components in order to understand it better. So the devices are communicating with the cloud management platform using machine-to-machine protocols. MQTT is the most common one. MQTT is a publish-subscribe protocol. The MQTT broker holds the topics, a sort of channels, communication channels. Devices can subscribe to topics, and once information will be published to a topic, all the subscribers will get it immediately. Usually there are also a device API. It's used to initialize the communication between the device and the cloud, and for example, get the one-time MQTT credentials for the MQTT session. There are also different databases on the cloud. In the user side, there is the user API and the web server. And in the middle, there are different services responsible to orchestrate the operations between the users and the devices. So during our research, we covered 3 main attack vectors: asset registration, weak security configurations, and vulnerabilities in the external API and interfaces. Potentially, those attack vectors could lead to different outcomes. We specifically focused on achieving remote code execution on devices over the cloud. Let's start with the first attack vector, the asset registration. So usually the cloud management feature is enabled by default on routers, but they are not linked to any cloud account, to any user. So users can register or claim their devices to their cloud account by manually entering the device identifier, such as the MAC address, the serial number, and the IMEI, which typically are labeled on the back of the device. Here you can see 2 examples. For example, in Teltonika Networks, they are using serial number and MAC address for registration. In Sierra Wireless, they are using the serial number and the IMEI. So if the device specifically, we discovered that this common registration mechanism that depends on non-secret identifiers is flawed. And if the device remains unregistered by the owner of the device, it actually exposes the device to takeover. And what it means, attackers can collect the identifiers in different ways using the internet. And once they have the identifiers of the devices, they can try to register those devices under their cloud account. So if the device remains unregistered, it will actually work. And now when the device is under the attacker account, it can fully control him using different features the cloud management platform offers. So let's see a few examples of how attackers can collect those identifiers, starting with Shodan. So using the Shodan API, we created a Python script. We searched for Sierra Wireless industrial cellular routers and gateways with the SNMP service exposed to the internet. And we queried using SNMP the serial number and the IMEI of the device. Here you can see some of the results. Now, having those identifiers, we can try to register the devices to our account. In a similar way, we did it for Teltonika Networks. We created a Python script, and we searched for SNMP exposed industrial cellular routers and gateways. Here you can see also some of the results, the serial number and the MAC address, and we can try to register the device to our cloud account. Another example would be Wiggle. Wiggle is a free and publicly available platform that stores information about Wi-Fi networks across the world. There are over 1 billion unique Wi-Fi records in this database. There are 2 filtering options, a basic one and an advanced one using their API. So since the Wi-Fi is a very common feature on industrial cellular routers and gateways, we can actually search for the MAC prefix of vendors that manufacturing industrial cellular routers. Here you can see an example. We searched for the MAC prefix of Teltonika, and we found over 140,000 results. Here is a record of one of them. So I actually censored the coordinates, the full MAC address, and the network name, because it's actually an oil field that is using an industrial cellular router with the Wi-Fi functionality of Teltonika. So having the MAC address, we can try to brute force the serial number, which is only 8 numbers. And having both identifiers, we can register the device to our account. The last example would be information exposure by the vendor. In the warranty check website of Sierra Wireless, users can check the warranty of their device by entering the serial number or the IMEI. And if the parameter is correct, it will link the another parameter as well. There is also a feature of uploading a file with a list of identifiers and check them at once. So we leverage that and the fact that IMEI is an ascending number. So we created a list of IMEIs starting with our lab device. And for the correct IMEIs that really exist, we got also the serial number. So in this way, we could get the serial number IMEI of all possible devices. And having those parameters, we can try to register devices to our account and then manage them. So how this device takeover translates to a remote code execution. So the attacker collected the identifiers, registered the device to his account, and how this actually translates to remote code execution. So let's take an example. In Teltonika Network Cloud Management Platform, they have the task manager feature. It allows the user to create a task and execute it on the chosen devices. So we created a reverse shell with the command and control IP and port executed, and we had a root on the device. So this was the first attack vector. Let's move on to the second attack vector, weak security configurations on different cloud components. Here we will focus on in-end network cloud management platform called Device Manager. In-end network is one of the leading vendors that manufacturing industrial cellular routers and gateways. We found a serious security misconfiguration in their MQTT broker part of the cloud management platform. Together with vulnerability on the device firmware, chaining this together with this vulnerability, we could get remote code execution on every cloud connected router, like thousands of tens of thousands with 0 click. So let's understand how the communication between the router and the device manager works. So once the device is boots, a weak registration is being performed. The router sends is the configured cloud account and the serial number. And if the serial number is valid and the cloud account is really exist, this device will be assigned under this email account. And one-time MQTT credentials will be sent to the router. Using them, the router will establish MQTT session with the cloud. Now, it's important to note that for each router that connects to the cloud, the MQTT broker holds 2 main topics: the task notice to publish tasks to the router, and the task update used by the router to publish the results for the tasks to the device manager. The ID part in the topic name is actually a 24 characters string, hexadecimal character string, that actually differentiates between each device's topics names. So 2 different routers connected to the cloud will have 2 different IDs, and it changes every new session. So now the router will subscribe to the task notice, will get a get config task, and will set this configuration file to the device manager. Now this is the generic flow once a device is booted and connected to the cloud. So for example, if an admin wants to upgrade the firmware, it clicks on the upgrade firmware button, and behind the scenes, the MQTT broker will send firmware upgrade commands. So let's take a look at 3 out of 5 vulnerabilities we found on the device manager. Chaining them together, we could get remote code execution on every device manager managed router. So starting with the first vulnerability, insufficient random values in the topic name. We perform the registration process over and over again with different serials and emails that we have. And we noticed for a very interesting behavior, we printed the results, the MQTT credentials, one-time credentials that we got back for the registration and the ID. And we noticed for a very interesting behavior, as you can see in the ID part, the 8 first hexadecimal characters are actually the timestamp of the registration. And the second part, 16 hexadecimal characters, are ascending by 2, increasing by 2 every registration. So because we did these registrations without waiting, we decided to do it again, but at this time to wait 5 minutes between each registration, as you can see. And in this time, we noticed that between the second registration we made and the third, the second part increased by 4 and not by 2. So we learned that probably another router connected to the cloud and got this specific ID. And the second part of the ID we know exactly. It ends with 2, with 472. And the first part, the 8 first hexadecimal characters, are the timestamp. It's 1 out of 300 options because in 5 minutes we have 300 options. So there are 300 options for this router ID. So knowing this vulnerability, it's actually led us to the second vulnerability. We decided to check if we can subscribe to those topics and if there is access control policy on this MQTT broker. And if there is no access control policy, we will get the last message that was written to this topic by the router, which is the configuration file that is sent to the MQTT broker. So we subscribe to all possible 300 options of the task update for this router. And after 175 attempts, we actually got something, and it's actually the configuration file of this router. So we can actually read from any router topic once we know its ID. So knowing that, we also decided to, knowing its ID, to change the configuration since the configuration is not encrypted. We changed the host name and send the setconfig command to the MQTT broker, and it's actually worked. It sent it to the router. So we actually, knowing the ID of the router, we can read this configuration, change it a little bit, and inject it back through the cloud management platform. So this leads us to the third vulnerability. We decided to check if we can reach also remote code execution. And for this, we checked the functions on the device firmware that's responsible to parse the configuration when the device is booted. So here you can see a few lines from the configuration. There is hundreds of lines in the configuration file. Those two parameters are very interesting, the auto-ping enable and auto-ping test. If the auto-ping enable is 1, this function, the ping action start, will be executed, and the parameter in the auto-ping test will be concatenated to a ping command and executed as a system. Okay, so since there is no check if the parameter of the IP address is really matched to an IP address pattern, we can actually concatenate a reversal command to it with ncat that actually exists on the firmware. And sending this configuration to the router will give us remote code execution. So let's see a demo. Of course, all the things that we did there is on our lab devices. We didn't harm any operational device in the world, so don't be worried about that. So in the left side, you can see the victim. In the right side, you can see the attacker. Okay. So the victim is enabling the cloud management platform with the account that you can see below. Now the online devices will be changed to 1 here. Okay, now the device is connected to the cloud. We will log out from the local web interface to see the device hostname. Okay, my router. Now this is the script, the exploit script. We're using here the cloud account of the attacker, the serial number that we want to attack. Actually, we have coded this parameter in order to not harm any router across the world. We can execute it without it. The host name that we want to change, and the IP address and the port of the attacker command and control server. Now running this exploit script, the script will get the configuration of the router from the cloud, will change it with the parameters, and inject it back. Now the router receives the configuration from the cloud, and it rebooted in order to load the new configuration. The host name changed to pond, and the router, after sending the ping, will connect to the attacker command and control. And now the attacker fully controls the device over the cloud. So this was the second attack vector. Let's move on to the third and last attack vector, the vulnerabilities in the external API and interfaces, vulnerabilities and not misconfigurations. Here we will focus on Teltonika Networks cloud management platform called RMS. Teltonika is one of the leading, if not the leading vendor of industrial cellular routers and gateways. We found vulnerabilities in the device API and in the web service, web interface. Chaining them together, we could perform an account takeover, leading to a remote code execution on all the routers under this specific account. So how the communication works between the routers and the cloud management platform. Once the device is booted, the RMS Connect executable will connect to the cloud management platform with hard-coded certificate and key. And the RMS Connect will send the device identifiers, as you can see in this picture, the serial number, the MAC address, the firmware version, and other identifiers. If the serial number and MAC address pair are a real pair of a device that's manufactured by Teltonika, it will send a one-time MQTT credentials, certificate, and key. Using them, the router will establish MQTT session with the RMS. Now, attackers can easily abuse this flow. Once attacker knows MAC address and a serial number of any Teltonika device that exists, it can impersonate to this device. The attacker can connect to the cloud with the hard-coded certificate and key, send those identifiers of this device. And the attacker will get these MQTT credentials and will connect with MQTT. Now the device that the attacker is impersonating to will work, but it will be DOS to the management feature of this device. The management feature will not work. Now this actually leads us to the second vulnerability we found. Here you can see the firmware version field that the router sends to the cloud, okay, by the RMS Connect, or the attacker that impersonates to the router. And this firmware version is actually displayed in the middle of the main page of the RMS, as you can see. And it's vulnerable to XSS. So once the user will only move the mouse over this firmware version, it will trigger the XSS vulnerability. We used the HTML tag underline, and you can see there is underline under the word check. So let's now talk about tunneling over the cloud, about this feature on Teltonika. Users can tunnel to their device local web services, like the web service, over the cloud platform. Okay, how does it work? Actually, using the MQTT session between the router and the cloud, the router will get a port forwarding command from the cloud management platform, okay, and asking to forward the port 80 of the device, the local web service, to a local port on a proxy server in the cloud. Now this local port on the proxy server in the cloud will be linked with a subdomain of RMS, of this Teltonika cloud management platform. And by browsing to this subdomain, it will actually, by anyone actually, I can send this link to you, and if you will browse to this subdomain, it will lead you to this router local web interface. So because the web policies on the RMS and especially the context security policy are too open, it actually allows loading of content also from external resources, like the link that we have, the link that we created, and how it can be used maliciously by attackers. So an attacker with his own device, okay, the attacker has his own device on his lab. This device is connected to the cloud. The attacker can get this link for his router local web service, this link of tunneling over the cloud. And then the attacker can connect with SSH to the device, stop the HTTP port service, and run instead a malicious web page. Now this malicious web page, this link actually, this link, the legitimate link of RMS of Teltonika, will lead over the cloud to the attacker a malicious web page fully controlled by the attacker. By browsing to this malicious web page, if the attacker sends it to a victim that is connected to the RMS cloud platform, it will execute this page with the cookies of the connected user. And we can actually use it in another way. As you remember the XSS vulnerability, we can use the HTML embed tag, and after it, this malicious link. And once the user will move the mouse over the XSS vulnerability, over the firmware version, the embed tag will load the malicious web page, and it will be executed with the with the victim cookies. So what we can do on this malicious web page, what the attacker can do in this malicious web page, as you remember in Teltonika, there is the task manager feature again. The attacker can create a reverse shell task with his command and control IP and port, and executed on all the routers under this cloud account. Now, before we see the demo, let's understand the full attack flow through an example. So there is an oil field with dozens of, oil company, sorry, with dozens of oil fields. In each oil field, they have an industrial cellular router of Teltonika. Now, this router, they're using also, the company is using the RMS for remote management of the industrial cellular routers and gateways. So the attacker found somehow a serial and MAC address of one of their devices, only one. Now, by knowing this serial number and MAC address of one of the routers, cloud managed routers, the attacker can, using the impersonation vulnerability, it can impersonate to this device, and through the firmware version field, inject the malicious web page with the embed tag. Now, after a week, after a few days, the admin of those routers will connect to the cloud platform. It will move the mouse over this malicious firmware, but only by moving the mouse over it. It will create the task, execute it on all the routers. The routers will connect to the attacker command and control, and the attacker can fully control them over the command and control server. Now, I said all the routers. It's actually not all of them. It's all except one, the one that the attacker is impersonating to, because the command for this router will be sent to the attacker because the attacker is impersonating to this router. So it's all the routers under the cloud account except the one that the attacker impersonating to. Let's see the demo now. So under this account, we have two routers, router 1 and router 2. In the exploit script, we are using the MAC address and the serial number of the device that we want to impersonate to. We will use the identifiers of the first device that you see. Now, we are not accessible to the router. We're only accessible to the cloud management platform. Running the command and control, the listening and cut, and then the exploit script. You can see there is only one firmware version. Now running the script and refreshing the page. Here you can see there is a new firmware version. just log out and log in to show that this is actually a stored XSS, refreshing the page. Both devices are online, everything seems okay. Now, just by moving the mouse over this firmware, the second router connected to the attacker command and control. If there were 20 routers, 19 connected to the attacker command and control. Running commands to show the firmware, the serial and the MAC address of the, as you can see, it's the second device, also sending pings. So this was the demo. Now a few recommendations for clients. The first recommendation, if you are not using the cloud management feature, validate that this feature is actually disabled to prevent a device takeover. If you are using the cloud management platform, before you are connecting your device for the first time to the internet, register the device to your account. So if it will be already registered to another account, you will be notified for that. And the third recommendation for clients, especially for industrial cellular routers and gateways with security features, once the router is compromised through the cloud, the security features are useless, okay? The attacker can remove the firewall and rules and manipulate the security feature. For example, use the VPN credentials in order to perform a lateral movement attack to the other side of the VPN connection. So I'm suggesting to the clients to separate the security to a different device between the local network and the router and use it only as a bridge to the internet. A few recommendations for vendors. Add additional secret to the registration. Here you can see that after we reported about this vulnerability to Teltonika, they added additional layer of security to the registration, a password that's known only for the owner of the device. So if the attacker somehow collected the identifiers, it cannot register the device to his cloud account. The second one is force the initial setup of default credentials, especially the SMP community string. If the device will be exposed to the internet, it will make the life very hard for attackers because search engines like Shodan and Sedis, usually they're using the default community strings for SNMP, the public, private, and admin. So if the vendor will force changing the default community string, those search engines won't be able to find the device. And the third recommendation for vendors is, since from a security perspective, the industrial IoT is not a regular IoT devices. They're used in industrial environments, and therefore they should be more secured. I'm suggesting to vendors to create sort of a new cloud with limited features, so like firmware upgrade and reboot, so users can choose whether they want a lot of security, a lot of features, and by that the attack surface will be increased, and use a limited cloud with limited features, only the features that they need, and it's simple mathematics. When you have limited features, the attack surface is lower. So a few takeaways from this research, starting with the first one. The cloud management feature is a big supply chain risk. So actually entering a third party into your network, and this third party is not only in your network, this party is in thousands of networks. And if attackers decide to target this specific company, they can get access to thousands of networks at once. The second takeaway is that users may not be aware that their devices contain a cloud management feature. And since this feature is by default, usually by default enabled, the devices can be compromised. So it's important to be aware what features the devices that you are using offer. And the third takeaway, when you are designing a network and you decide to use the same device for different purposes. For example, use a security device with security features, also as a Wi-Fi access point, and also as industrial cellular routers with cloud management. It will lower the security of your network. So it's important to be aware for this. It may be cheaper, but it will lower the security of your network. So that's actually everything. If you have any questions, you can catch me up or contact me with LinkedIn. Next week, we will release a full white paper about this research. So if you want more details, check our website. And any questions, if you have. Thank you. Thanks.
So how much, like all of those attacks which you showed, how much are they automatable? You know, like for the attacker, can they perform it on large scale?
For example, as you saw with the vulnerability that we found in Internet network, we actually could run this script, only run it on an AWS server, and this script will hunt for every new device that connects to the cloud. And once a device will connect to a cloud, if it's for the first time or it's lost the internet and connected again, our script will find this device, because the script, what it does behind the scenes is a registration every 5 minutes. And once it found his IDs, all the possible IDs, it will get his configuration, change it with the attacker parameters, and will send it to the device through the cloud, and will get a remote code execution on the device. It can be like thousands, just by thousands of compromised devices, just by running this specific script. For the Teltonica example, just by knowing a serial number and MAC address of cloud managed device, you can perform this attack. And you need to wait that the user will connect to the cloud and move the mouse in the middle of the main page. So having those both exploits, you can reach remote code execution on like hundreds or thousands of sites and the networks, I think, in weeks or days.
I'd like to ask how quickly the vendors actually work with you to get the issues resolved. That's the first point. And the second point is, this is actually really, really serious. Do you know if there was any investigation done after the fact to determine if something like this hadn't already happened?
So, thank you for the questions. For the first question, after I reported them, it's take like 3 or 4 months until the full patch. So they really did it quick. And they also asked me to check if the system is still vulnerable, and I did it for them. And for the second question, I asked one of the vendors if he can check if there were an attack on their logs or something. And I think they said me no, but I can check that again and tell them. So also, if they were compromised, I don't think that they will tell me. But it's serious attack vector, and it's important to be aware to this, especially if you own these devices on your network.
I have one more question. So what are the prerequisites for all of these attacks? So the cloud take over, basically, so the attacker needs to take over the cloud, be in the cloud, find the right tenant?
What's interesting about this attack scenario, that I didn't compromise the cloud, okay? I didn't get remote code execution on cloud service, nothing. Just by misconfigurations or vulnerabilities on internet-facing components. Okay, I didn't compromise any cloud account. So it's also an attack vector. It also can be attack vectors. It's more a nation states attack. But in this specific research, we not did it.
If you're a company that has the device problem, isn't it remediating just simple as factory reset and not turning on the cloud feature?
So if you are not using the cloud feature, this kind of attack can be done. But if the attacker already used this kind of attack and compromise the device, it can perform a lateral movement inside the network and be in another place.
But if you've already been pawned and you want to remediate it so they can't get access to your device, can't they simply just reset the device and then reconfigure it whilst it's offline?
I think it can. I think it's a good idea, but also to do it on all the devices that's reachable to this device that directly connected to him. Because if the attacker propagates to them, it can use it, it's a gateway to the internet.
Yeah, but if they back up their config for the compromise, they can easily load the config back on to the devices.
Yeah, so if you are doing it, it can be a good...
Because usually you would back up your config in case you have been compromised, so you can revert back to the state that was previous to the compromise.
Yes, it's good to do it, but also to the devices next to it. So that's all. Thank you.